Okay, today's topic is normalization, which comes under logical database design. Now you all may know that you cannot develop a proper database application without having a proper without designing it properly. So as I told before, normalization is a database design technique, but it begins by examining the relationships between attributes, and these relationships between attributes are called functional dependencies. So here we do series of tests to identify how these attributes can be grouped in an optimal way. In doing that, we should be able to cater for the data requirements of the company, and eventually we will get a set of relations. So the purpose of normalization is, as I explained before, to identify a suitable set of relations to cater for the data requirements of a company. So when I say a suitable set of relations, that should have the following characteristics. Now we should be able to get the minimal number of attributes, and these attributes should be able to support the data requirements, and these attributes should have a close logical relationship, and then there should be minimal data redundancy. So there should be data integrity, and because of this minimal data redundancy and the minimal number of attributes, there will be storage space efficiency, because we won't be using the space to store unnecessary data. And if we have a look at this diagram, you can see how normalization fits into the database design process. Now there is one coming from the top, and there is one process coming from the bottom. And now you may be familiar with ER modeling, and if you design your database, or if you use the ER modeling approach to design your database, you know that after drawing the ER diagram, you have to do mapping. There is a mapping process to obtain a well designed set of relations. And now if you start with normalization, you start with a set of attributes, and then you find the functional dependencies between the attributes, and then you group these attributes into relations in an optimal way. So normalization is the bottom up approach, and ER modeling would be the top down approach with respect to the database design phase. Now whenever you derive a set of relations, you can again use normalization as a validation technique to see whether whether there is a close logical relationship between these attributes. Now our aim is to minimize data redundancy, as I explained before. So we have to group attributes in a way to minimize data redundancy. Now if we have achieved this aim, then there would be a minimum number of update operations, and that means it will reduce the data inconsistencies, and then again there would be a reduction in the file storage cost. Now if we consider this example, now here you can see that there is a relation called employee with the attributes employee ID, e-name, birth date, address and department number, and there is another relation called department with the attributes department number, department name and department manager's ID. Now instead of these two relations, let's suppose that there exists a relation called employee department, and this employee department would have a combination of the attributes that are in the two relations employee and department. So, employee department will have the attributes employee ID, employee name, birth date, address, department number, department name and department manager's ID. Now, I am going to illustrate the how data redundancy and update anomalies occur when there is no relationship between the attributes in a relation. So, if I give you an introduction to update anomalies can be classified as insertion, deletion or modification anomalies. Now let us consider them one by one. First we consider insertion anomalies. So, there are two types. Now, I am going to illustrate these anomalies using the relation called employee department. Now, by looking at the relation, the attributes in the relation, you may identify that if you want to recruit a new employee or if you want to insert a record of a new employee into the relation called employee department, then we need to fill in the department details as well, department details relevant to that particular employee, and then we cannot insert a new department or we cannot create details of a new department that has no employees, because every time when we want to insert a new record for a department, then there should be employees to it. And if we consider the deletion anomalies with respect to this employee department relation, now if we delete from this relation the last employee working for a particular department, then what would happen is that the information from the database. And if we consider the modification anomalies, we can again describe that using employee department relation. Now, if we want to change some values with respect to a particular department, then we have to update all the tuples of all the employees who work in that department, because if we take a particular department, there can be many employees working for that department. So, if we change a value relevant to a department, then we have to check the employees working for the department and update it all the corresponding places. So, we can avoid these kind of anomalies by decomposing this original relation, that is employee department, into two relations called employee and department relations, as the way I showed before. So, now the process of normalization is happening through decomposition. So, decompose a given set of attributes into set of relations, and when we do so, it must confirm two important properties. Now, first one is called a lossless join or non-additive join property. Now, what does it mean? Now, when we preserve this property, it avoids the possibility of generating spurious tuples or spurious tuples with respect to the relation schema created after decomposition. So, these spurious tuples are the ones that do not exist in the records originally. and then the other property is dependency preservation property. When the dependency preservation property is there, that ensures that all the most of the functional dependencies hold after the decomposition process. So, again we consider another relation to illustrate this spurious tuple situation, generation of spurious tuple situation. Now, let us consider the relation employee project, and there you have attributes called employee ID, project number, hours, employee name, project name and project location. And I have taken 3 records to illustrate the generation of spurious tuples. And now these are the records, these are the existing records, and as you can see there are 3 records only. And now then we consider the 2 relations instead of employee project. One could be employee location. So, for employee location we take the attributes employee name and project location, and for employee project 1 relation we take the other attributes such as employee ID, project number, hours, project name and project location. So, that is how we decompose the original employee project relation into 2 other relations. So, you can see how the data is divided between these 2 relations. So, in employee project 1 you get the employee ID, project number, hours, project name and project location, and for employee location you get employee name and the details relevant to employee name and project location. So, now if we want to create the original relation which is the employee project, then we have to combine the records in these 2 relations. Now, here we have to connect these 2 relations, or we have to join these 2 relations through the attribute called project location. So, the Colombo record will get joined with Colombo record in employee location relation, and Candy records relevant to Candy would get joined with the Candy records in employee location relation. So, when we do that process, this is what we get. So, as you can see, there is originally I showed you certain number of records, but here after joining these 2 relations you can see that there exists this record which is in orange, and this did not exist originally in the within the data records. So, why did it happen? Now, you can see that this is part of the records that would be generated after joining these 2 relations, and the reason, what would be the reason for getting this record that was not there originally? Now, the reason is that we joined these 2 relations using an attribute called P location, that is the location of the project, and you can see that it is not a foreign key or a primary key in the employee project 1 relation. So, because of that reason you can see that a record that was not originally there has been created, and this is known as a spurious tuple, a spurious tuple. Now, let us have a look at what functional dependency is, Now, I said that in the normalization process, we get a set of attributes, and then we have to create set of relations using combining these attributes in an optimal way, and in doing that we use this thing called functional dependencies between attributes. So, because of that, it is necessary to see what the functional dependencies are. Now, what does it describe? Functional dependency describes the relationship between attributes in a relation. For example, if A and B are attributes in a generic relation called R, then we can say that if B is functionally dependent on A, we denote that by using an arrow like this. So, this arrow is pointing to B, which means that B depends on A, and here again it denotes that A is associated with exactly one value of B. And when a functional dependency exists between attributes, so the attribute or group of attributes on the left hand side of the arrow is called the determinant. Now, if there is a functional dependency between A and B, and if the arrow is pointing to B, we say that A is the determinant of B. So, capital F is the notation that we use to denote the set of functional dependencies that exist with respect to a particular relation R. And there are obvious functional dependencies, and now some of the dependencies can be inferred or deduced from the given functional dependencies, but it is not possible to specify all possible functional dependencies for a given situation. Now, for example, if each department has one manager, department number uniquely determines the manager. So, we can denote it as department number is the determinant of the manager, or we can use this arrow pointing to the manager employee ID, and again we can have another functional dependency between manager and the manager's phone. We can say that manager is the determinant of the manager's phone. So, these two dependencies, or these are the given dependencies. So, from these two dependencies we can say that it implies the department number is the determinant of the manager's phone. So, as you can see, this is an inferred dependency. It was not originally there, but we deduce it from the two dependencies given above. So, formally the set of all dependencies that include F as well as all dependencies that can be inferred from F called the closure of F, and that is denoted by the symbol F plus. So, these are the functional dependencies given in F. So, that is employee ID is the determinant of employee name, birth date, address and department number, and department number is the determinant of department name and manager ID. So, these are the given functional dependencies, and there can be inferred dependencies such as employee ID is the determinant of department name and manager ID, because we can see that department number there is a functional dependency between department number. Department number is the determinant of department manager. So because of sensitive, we can deduce that employee ID would be the determinant of department name and manager ID. And again we can say from the department number functional dependency that department number is the determinant of department name. So these are the inferred dependencies, and so all these together would be called the closure of F, and this would be denoted by F plus. So there are axioms about the inferred functional dependencies. Now here we consider A, B and C as subsets of the attributes of a particular relation R. Now for example, there is this feature called reflexivity, and that means if B is a subset of A, then we can say that A is the determinant of B. And then there is this feature called augmentation. It says if A is the determinant of B, then we can add the same attributes to both sides, and we can deduce that A and C are the determinants of B and C. And this then there exists this transitivity property, that is if A is the determinant of B and B is the determinant of C, then we can infer that A is the determinant of C, that is through transitivity. And then there is another property called projectivity, that is if A is the determinant of both B and C, then we can infer that A is the determinant of B. And then there exists union property, that is if A is the determinant of B and A is the determinant of C, then we can infer that A is the determinant of both B and C. Then we come to the process of normalization. Now you all know what a functional dependency is and the purpose of normalization, and that we can avoid update and anomalies if we perform the normalization process properly. So now the process of normalization is a technique for analyzing a relation based on its primary key and the functional dependencies between attributes. Now this is executed as a series of steps, and each step will correspond to a specific normal form, and each normal form has certain properties. And as normalization proceeds, relations will become more restricted, and they will become less vulnerable to update anomalies. So now when we proceed through the normalization process, there would be a very close relationship between the attributes in that relation. Now we can diagrammatically illustrate the normal forms, and as you can see, it starts there is first normal form, second normal form and third normal form, and then comes the Boy Scout normal form, and there are some more normal forms such as fourth normal forms, fifth normal form. but we have to at least achieve either the third normal form or the Boyce-Codd normal form with respect to the relations, because first normal form and second normal form would still be subject to update anomalies and would not be adequate. So, it is important that we achieve at least third normal form or Boyce-Codd normal form with respect to relations, in deriving relations. So, for this I have taken an example to illustrate the normalization process, and I have as the example I took purchase order application, and as you can see, there are attributes for a particular purchase order, purchase order number, purchase order date, employee code that will reflect who has written the purchase order, and then the supplier number, supplier name, the parts relevant to a particular order, and part description, and the quantities. So, these are the attributes, and as you can see, these are the records relevant to a particular purchase order, and for example, for purchase order number 111, there is purchase order date and the code of the employee, supplier number, supplier name, and there are a number of parts for a particular purchase order, and it is the same situation with respect to other purchase orders. So, the situation is such that there could be number of parts there could be many parts associated with a particular purchase order. So, we say that this relation is in zeroth normal form, or this is an unnormalized relation. Why do we say like that? Now, we say that a relation is in its first normal form if all attributes are atomic. So, here in this example you can see that these attributes are not atomic, the part number, part description, part quantity, because there can be so many parts for a particular purchase order number. So, because of that reason, this part numbers are not atomic. There exist many parts for a particular purchase order. So because of that reason, the original set of attributes or the original relation is known as an unnormalized relation. So, a relation would be considered as in its first normal form if all its attributes are atomic, that is, there are no repeating groups. There shouldn't be any repeating groups, and each attribute is a primitive one. There should not be list or sets, but with respect to the original relation, you could see that there were repeating groups with respect to part numbers, and it was like a set of parts for a particular purchase order. And when they are in when a relation is in first normal form, there should be non-decomposable data item, and each data item should have a single value. So, if we consider the original set of attributes for a purchase order, as I explained before, it is in zeroth normal form or it is in unnormalized form, because within a single purchase order we can find several part numbers, as I showed before with respect to its records, part numbers, part descriptions, and part quantities. So, we can identify that part orders can be decomposed. So, we can decompose this part in this purchase order relation, and then so these are the actions required with respect to the first normal form. First, we have to examine for repeat groups of data, and then we have to remove repeat groups from relation. Then we have to create a new relation to include these repeated data. Then what do? We include key of the 0th normal form to the new relation, and after doing all this, we determine the key of the new relation. So, this is the result you see after achieving the first normal form. So, you can see there is purchase order relation, and there is another relation called purchase order part. Here you can see that we have taken the repeating group out, that is part number, part description and part quantity, and that has been associated with the primary key of the original relation, and then here we determine the primary key. So, the primary key of this would be purchase order number and part number, and the primary key of this would be purchase order number. So, after going through the first normal form process, first normalization process with respect to the first normal form, this is the result we get. Now, what are the problems associated with first normal form? Why it would be not adequate? Now, we can still encounter the update anomalies, some update anomalies with respect to first normal form. First one is the insert problem, because now with respect to this relation, we can recognize that we cannot get the available parts until an order is placed with respect to those parts. You know, there could be parts in stock, but we cannot there is no way to get to know about these parts until an order is placed, because the parts, in order to insert parts, they have to be associated with a purchase order. And then comes the delete problem. Now, that is called deletion anomaly. Now, if we cancel a purchase order, the information or the data relevant to some parts would be lost. Now, for example, I have given that part number, if we delete part number 7 from the given relation, you can see that there is only one record with respect to part number 7, and if we delete, if that purchase order is deleted, then all the information relevant to part number 7 would be lost. And there exists update anomaly. Now, if we want to change a description of a particular part, then we have to get all the occurrences of that part, and then we have to do the perform the update process. For example, if we have a look at part number 3, you can see that there are several purchase order numbers associated with part number 3, and if we want to change the description of this particular part, we have to change it everywhere. So, if we change it at only one particular place, and if we don't do that update at for the other records, then there would be an inconsistency. So, these are the anomalies or the problems associated with the first normal form. So, we come to the second normal form. Second normal form is based on the concept of full functional dependency. Now you know what a functional dependency is. Now then what is a full functional dependency? Now we say that a functional dependency, that is where consider these two sets of attributes or attributes as x and y. So, if x is the determinant of y, then we say that there is a full functional dependency if removal of any attribute a from x means that the dependency does not hold anymore. So, x could be one attribute or set of attributes. Now, if we remove an attribute a from x, then if there is a full functional dependency, then this x y dependency does, and then there is a partial dependency. What is a partial dependency? Now, for example, if we consider the same functional dependency x and y, x is the determinant of y. So, if an attribute or some attributes a that is part of x, that are parts of x can be removed from x, and if the dependency still holds, that means there exists a partial dependency between x and y. Now, if we illustrate this through an example, we can take employee ID and project number as the determinant of the number of hours that an employee is working for a particular project. So, employee ID and project number together determines the number of hours that an employee is working for a particular project. Now, this is called full functional dependency, because we can't say that employee ID is only the employee ID is the determinant of number of hours, or the project number only would be the determinant of the number of hours, because they have to come together to determine the number of hours that an employee is working for a particular project. However, if we consider the dependency employee ID and project number are the determinant of employee name, it can be considered as a partial dependency, as employee ID could be the only determinant of employee name. So, even if you take project number out, we can say that this dependency holds, that is employee ID is the determinant of employee name. So, that is known as the partial dependency. So, the second normal form depends on the concept called full functional dependency. A relation is in second normal form if it is in first normal form, and every non-key attribute is dependent on the whole key. So, that is the concept associated with the second normal form, which means all the non-key attributes do not depend on part of the primary part of the key. All the attributes, all the non-key attributes should depend on the whole key. So, that is the concept of second normal form. So, we will analyze it against the example that we are illustrating. Now, you know that we decompose the original relation into two relations. and from that we got purchase order part relation, and you can see that purchase order part relation has got these attributes: purchase order number, part description and part quantity. And you can understand that part description will depend only on part number. Part description will depend only on part number. Here the key would be a composite key, that is purchase order number and part number. Part description, it will depend on only on the part number, which is key of this relation part order part. So these are the records, and we can see that part description depends on part number and not on the purchase order number. So before, second normal form deals with the relationship attributes and the key attribute. So it is actually relevant when the key is composite, that is when the key consists of several attributes. So what are the actions required for the second normal process? First we have to consider whether the relation has a concatenated key or whether that relation has a composite key, and then we have to check each attribute against the whole key, that is against the composite key, each and every non-key attribute against the composite key, and remove attribute and partial key to new relation. That is, if an attribute, if a non-key attribute depends only on a part of the primary key, then we have to remove that attribute and the partial key to a new relation. So the situation would be something like this. We had one relation called purchase order part, and after going through the second normal form, we get two relations, that is part and part order part. So we discussed that part description will only depend on part number, which is a part of the original primary key, composite key, that is purchase order number and part number. So what did we do here? We took the part description out with the and associated that with the partial key, and we created a new relation. We call it as a part relation. So after going through the second normal form, we have decomposed part order part relation into two relations, part and part order part. Part will have part number and part description, and part order part will have part number, part quantity and part order purchase order number. So this is how the purchase order relation will look like after going through the second normal form. So you can see that eventually we have got three relations, part order part. We decompose part order part to get these two relations, part and part order part, and then to get the two relations, part and purchase order part, and then we get another relation called purchase order, which was there after going through the first normal form. Now let's have a look at this example. We have this relation called employee project. Employee project has got a set of attributes: employee ID, project number, hours, employee name, and project location. So the functional dependencies have been given below. They say that employee ID and project number are the determinant of hours. That is, employee ID and project number will together determine the number of hours that an employee is working for a particular project. And then there exists functional dependency between employee ID and employee name. And there exists another functional dependency, that is project number would be the determinant of project name and project location. So when we normalize this into the second normal form, what are the relations that we get? Now, as you can see, this is not in second normal form. Why I am saying that is because you can see that in employee project relation, employee ID and project name will form a composite key, and only number of hours would depend on the composite key. That is, there exists full functional dependency between the composite key and the hours. But if you consider employee name, there exists only a partial dependency, because employee name will depend only on the employee ID, which is a part of the composite key. And then you can see that project name and project location also depend on part of the key, that is project number. So employee name does not fully functionally depend on the key, whole key, and project name and project location also, these two attributes also do not fully functionally depend on the whole key of employee project relation. So after going through the second normal form, we can get three relations: employee project with the attributes employee ID, project number and the hours, and then we take employee name out from employee project relation and associate that with the key part of the key employee ID, and that relation is called employee or emp, and the primary key would be employee ID. And likewise, we create another relation called project, and the two attributes project name and project location are associated with the part of the original primary key, that is project number, and for this relation project number would be the primary key. So this is in its second normal form now. So still there are problems associated with second normal form, and it is not adequate a relation to be only in its second normal form. So what are the problems associated with second normal form? Now I am explaining this with respect to the example that I am illustrating. It is not possible to get to know about the suppliers until an order is placed. Now, for example, if we go back to the go back to these relations here, you can see that there are suppliers in purchase order relation, and till a purchase order is placed, it is not possible to get to know about the suppliers. And then there is a delete problem. Now, if we cancel a purchase order, then we might lose information about suppliers. For example, here I have taken purchase order 116, and if we delete the purchase order 116, you can see supplier number 100 exists only with respect to purchase order number 116. If we delete the record 116, then we will lose the information relevant to supplier number 100. And there exist update problems as well. Now the problem here is that if we need to do some changes relevant to suppliers, we need to change every record in purchase order containing that particular supplier. Now here I have taken supplier 222, and if we need to change something, some information relevant to supplier number 222, then you can see that there exist number of purchase orders relevant to supplier number 222. So if we do a change with respect to that particular supplier number, then we have to do that change with respect to all the other records in the purchase order relation. So we have to go through this third normal form to avoid the anomalies that are associated with the second normal form. Now what is the third normal form? A relation is in third normal form if it is in second normal form and each non-key attribute is only dependent on the whole key and not dependent on any non-key attribute. So the concept here is that the relation for a relation to be in the third normal form, first it should be in second normal form and each non-key attribute should only depend on the whole key and it should not depend on any non-key attribute. So here the idea is to eliminate transitive dependencies. So transitive dependency, I explained it before, it would be something like if B depends on A and if C depends on B, then we can imply that C depends on A. So now I am using the same example to illustrate the third normal form. Now you may remember the attributes relevant to purchase order relation: purchase order number, purchase order date, employee code, supplier number and supplier name. Now here you know that supplier name is a non-key field dependent on another non-key field, that is supplier number. So that is in addition to be dependent on the key which is the purchase order number here. So we considered that they all depend on all the non-key attributes are depending on the key here, purchase order number, but we can understand that supplier number is not a key field and supplier name is not a key field, and supplier name, which is a non-key field, will depend on also on supplier number, which is a non-key field here. So the third normal form basically deals with the relationship between non-key fields. So as I explained before, there exists a relationship between the non-key fields in the purchase order relation. Those are the supplier number and the supplier name. So, here in the third normal form, it considers that a non-key field cannot be a fact about another non-key field. So, what are the actions required to perform to make a relation to be in its third normal form? So, the first action would be to check whether there exists whether a non-key attribute depends on another non-key attribute, and then if there exist non-key attributes that are depending on other non-key attributes, then we have to remove those non-key attributes and form a relation. So, for that we have to create a new relation that consists of the attributes that consist of those non-key attributes and the other non-key attributes that they depend on. Then we have to determine the key of these new the keys of these new relations. Now, here you can see that purchase order has been decomposed into two relations, supplier and purchase order, and based on the actions that I described before, you can see that earlier supplier name was a non-key field and supplier number was a non-key field, and now that we have taken supplier name out from purchase order relation and we have associated that with supplier number, which was a non-key field in purchase order, and for this we have created a new relation called supplier, and for that new relation supplier we have determined the primary key as the supplier number. So, if we consider the original purchase order relation, when it is in its third normal form, we can see that we have got four relations. We have decomposed the original unnormalized relation into four relations when it comes to third normal form. So, there exist further normal forms. They are BCNF or Boy's Codd normal form, and there can be fourth normal form and fifth normal form as well. But as I explained before, normalization up to third normal form would be quite sufficient, and the other normal forms such as fourth and fifth will not be practically enforced most of the time. So, the reason for having further normal forms would be that third normal form also will not guarantee that all anomalies would be removed. So, that is why further normalization or further normal forms have been considered. So, from these normal forms, we would only consider Boy's Codd normal form. Now, to illustrate that, I took one simple example, that is the relation teach with the relation teach has got three attributes: student, course, instructor, and the dependencies have been given as student and course would be the determinant of the attribute instructor, and then there is another dependency which says instructor would be the determinant of the course. So, if we consider this relation, we can consider student course as a candidate key. Now, this relation is in third normal form, but it is not in Boy's Codd normal form. So, if you consider student course as the key of this relation, you can understand that this relation is in third normal form, but it is not in Boy's code normal form. So, what are the anomalies here in this teach relation? Now, for example, if we need to add an instructor called Silva for the database course, we have to wait till we get an appropriate student to learn that or to study that subject. So, it is not possible to insert records in instructors details without students. And also deleting a record will also delete other data. For example, if an instructor has got only one student, then deleting that student will also erase the instructor's data. So, the solution would be to divide this relation into two. So, now here I have I have decomposed that into two relations, instructor course and instructor student. So, here the situation is that the attribute that is a determinant but not a key must be placed in a separate relation, and then that should become a key in that relation. Now, you saw with respect to this relation, instructor is a determinant. If I show you the previous slide, instructor is a determinant. This is in third normal form, but according to the given functional dependencies, instructor is a determinant of the course. So, here what has been done is that that has been placed in a separate relation and that has been made as a key. So, there are other possible ways of decomposing it like course and student, course and instructor, and student and instructor, student and course. So, there are so many ways of decomposing this, but those will generate spurious tuples. So, if we analyze the difference between third normal form and Boy's code normal form, you can see that if we use the given formal sort of explanation here, a relation schema R is in third normal form whenever there is a functional dependency exists between the attributes x and a, that is when x becomes the determinant of a, x could be the super key of the relation R, or a could be a prime attribute of R. Prime attribute, what is a prime attribute? Prime attribute would be the could be a part of any candidate key. Prime attribute would be an attribute which could be a part of any candidate key. So, the relation teach is in third normal form, because if we consider the functional dependency instructor and course, you can see that course is part of the attribute course is a prime attribute. So, when that holds, a relation is in third normal form. So, x could be a super key of R, or a could be a prime attribute of R. Now, with respect to Boyce code normal form, you can see that the second situation has been removed. That is, a relation schema R is in Boyce code normal form if there exists a functional dependency between the two attributes x and a, then x should only be a superkey of the relation R, and this situation where a could be a prime attribute of R has been removed from Boyce code normal form. So, when there exists a functional dependency between the attributes, then always the determinant should be the superkey. So, that would be the end of the normalization lesson, and I hope that you all got an overall overview of what the why we are performing normalization and where will it fit into the database design process, and why do we have to perform normalization, and the normal forms up to BCNF. Thank you very much.